Here's another relatively simple problem involving a volume. We want to find the maximum volume cone. Basically, we're going to start with a flat piece of metal, and we're going to cut a notch out of it, like is shown in the picture here. And then we're going to attach this end to this end and form a seam, but when it's bent in that way, it will form a cone-shaped, I guess, drinking cup, I suppose. So you can see what they're doing here. A cone is constructed by cutting a sector from a circular sheet of metal with radius 20. The cut sheet is then folded up and welded. See the picture, so they got it there. Find the radius and height of the cone with maximum volume. So find the radius and height of the cone. So basically finding the dimensions. So let me circle that because that's what they want. Radius and height is what we're going to be looking for. Cone with maximum volume. First of all, to get the volume of a cone, the formula is 1/3. So I'm going to the volume of the cone that is V equals 1/3 times the area of the base. So that's pi r squared will be my area of my base. Pi r squared times the height times h. And I'm left with trying to figure out a connection between r and h. Well, hopefully this doesn't take much, that you can see that the height is r. Sorry, the height is h. This is r, and you can see a right triangle with a hypotenuse of 20. So, in case you cannot see it, I'll draw it down here. We have this going on. The 20 is this slant. And then h is this. And then r is the base. So the Pythagorean theorem tells us that r squared plus h squared equals 20 squared. So I think what might be the easiest thing to do is I have an r squared in the volume. I can solve for r squared here and make the r go away without having to worry about roots or anything like that. So r squared equals 20 squared is 400. 400 minus h squared. So when I substitute that into here, I'm going to put this 400 minus h squared in where I see r squared. And the volume becomes a function of h. So I have 1/3 pi r squared, that was the 400, minus h squared, and then times h. Now, what are the possibilities here? H is our variable, so what's the lowest h could be? Well, if they simply, let's do this. H equals 0 would be something where they just notch this but don't actually cut anything out. So you'll have like a circle where you just notch 20. I don't know what the purpose of that would be, but it would be flat. And it would certainly have no volume. Another thing you could do is that h equals 20. The height is 20. That means you would just have a thin, it wouldn't even be a cylinder, it would just be this. This would be the extreme cases. Both of these represent extreme cases, and they both represent a volume of 0. So whatever I find is going to be the answer. Notice that 0 is less than or equal to h is less than or equal to 20. All right, let me take the derivative. Well, actually, let me write v a little better. V of h equals, I'm going to multiply the h through. And I'll write as pi over 3. It seems a little more compact. 400h minus h cubed. And then when I take the derivative, v prime of h, just ignore the pi over 3, just write it though. Pi over 3 times 400 minus 3h squared. And set that equal to 0. Well, like I said, the pi over 3 has no importance here. This is the part that will equal 0. So I'll have 400 equals 3h squared. I'll divide by 3. 400 over 3 equals h squared, and then I'll take the square root. So h will equal 20 over the square root of 3. And then r, where did r go? R is 400, r squared is 400 minus h squared. So right here I'll have to do a root if I want to get what r is. So r equals the square root of 400 minus h squared. That will equal 400 minus, well, there's h squared right there, 400 over 3. That will give me, if I think of this as 1200 over 3, this will be the square root of 800 over 3. And I don't know if you care if I even simplify it, but I think I'll take a 400 out front. And when you take the square root of 400, it's 20. So I'll have 20 times the square root of 2/3. So that's r. And that's h. So I told you it wasn't that hard of a problem. Pretty simple.